two new classes from Java library, integer and double. And by the way, for every other primitive data type like Boolean and byte, there are corresponding uppercase names of classes that provide us utility to do some common tasks with primitive data types. I'll give you an example. Just once again, moving on to next topic. Okay, so number one, I may create an integer value, right? Something like this. But I cannot initialize this by providing a string, like for instance 123. This just doesn't work. Well, you need to provide an integer, then it works. But what if my information, the actual value, originates as a string? Maybe it's loaded from a file. Maybe somehow it was processed by the user and came as part of the whole list of parameters that we were able to capture as a string. In other words, I have a string already with str value, right? Something like this. Str value equals 123. How can I get it here to become the value of my integer? So let's first just add semicolon here as expected. And this is what normally you can do. Integer, which is the name of the class in Java library, and then parse int. That's a pretty standard way of doing it. And then we can check this by printing it once again. Print line, and we'll print the value. Okay, so that's just simple as this. So sometimes primitive data type values originate in strings and not in some kind of numeric values to begin with. So in fact, when we're loading some sort of a file with information like a spreadsheet or something, it always contains a collection of strings. Oftentimes you get this as a result of a database query. Many ways of obtaining values originally as strings. So instantly you want to convert it, and here's the parse int. So if I run this, you see it prints 123. So I was able to extract integer nicely from here. A warning, however, if I have some kind of garbage value right here, so it's not really an integer, and if I run it, you see what happens? This throws an exception. So parse int, if it's unhappy with something that we provided right here, it will throw an exception, and it says number format exception. Okay, so this, and it tells us that this simply, it doesn't know how to convert this to an integer. So we will again discuss exceptions soon, but for now I'll just leave it as this, so you know the information that for now we'll just promise everything that we do will have perfect data formats to avoid any kind of unnecessary problems related to these types of errors with data types and bad formats and stuff like that. Similarly, I can just copy and paste this, and of course I can do the same thing for double a value and whatever, right? So we can try 3.14, which is looks like a pi number, and so here we're gonna say double a value, and of course this needs to change to a double. So double, and also parse double. So this is the new method, and then we also need to change this to a double to demonstrate. And Of course, this will be d value. We somehow need to give it name different from this value, double, and so forth. So we'll try printing this. You can see that now I get my double from this string. So this works. So these are pretty straightforward situations where we need this kind of conversion. And remember, this is how you do it. You just find the correct wrapper class for these primitive data types, and it's very easy to remember them. Their names are like integer, double, boolean, and there is also the second pretty popular method here is to convert them to string. So of course print line takes this value, but internally it gets a double from us. So how does it go to a string to print it? Well, it's using toString method, and that's how it works. So basically we could assign our double to a string by doing this. Again, we could just reuse this, right? We can say string value equals, if we want this string back, can say double toString, right? toString, and we can take this double value and provide it as a parameter. So now we're doing the opposite thing. We're taking the double data type right here and converting it back to a string. This is of course a string reference, and we'll print it, and hopefully it stays the same. So again, this time we're still printing the same value. We just switched to print a string, I guess. Okay, so obviously it works the same way. So these are pretty popular methods: parse double, parse int, parse boolean, parse character. All of these methods exist in the corresponding wrapper classes. I call them wrapper classes for primitive data types. And you can use this to convert between strings and built-in data types or primitive data types. So that's same example we already tried. We already talked about comparing strings and converting strings. So these are examples that we've used. So comparing strings, I'm just going to browse through this. Just a reminder that a logical comparison between two strings has to rely on compare to. So we can compare the strings this way as opposed to using comparison operators like less or greater. So compare to will return a negative result if the strings are, for example, if this string contains text something like A, B, C, right? A, B, C, and this string contains text such as D, E, F, right? So alphabetically, so this is D, E, F. Alphabetically, A, B, C, like in the index part of your textbook, would appear earlier than D, E, F. So compare to will actually return a negative result when this is the case. Essentially, logically, this is less than this. And then if they're equal, the result will be 0, and if it's positive, the result will be greater than. We will use these comparison type of methods which are built into strings when we talk about arrays of objects, and when we need to be able to sort this array somehow, rearrange the order of elements inside an array or list of elements. We will definitely use this method.